already pretty quick video today. It's just proof by contradiction. And what that means is you're proving something not by going from the left-hand side to the right-hand side or proving an equality, but instead you're proving that the opposite can never be true. And so what you'd be doing is saying, we're trying to prove some statement, P then Q. So what we would do is we assume not P then Q, and then we'll find contradiction in the proof. And so if you remember, the negation of this is P and not Q. And so what we're going to prove is a rule that you learn in elementary school. It's law of zero products. And what this states is that for all the real numbers, A or B that are real, when A times B equals 0, A equals 0 or B equals 0. So that's saying, if you multiply two numbers together and the output's 0, then you can see one of the two is 0. The most common time you're going to use this is factoring a quadratic, where let's say you have x minus 4 times x plus 1 equals 0. You solve this by trying to figure out when this is 0 and when this is 0, which is the exact same as what the law of zero product states. Alright, and now this won't take up too much space. We're just going to prove it. Alright, so we're going to start off with the left-hand side. So we're going to start off with P. So not P then Q. So we're going to start off with P. So we have A times B equals 0. That's going to be our given. And what we're trying to find is a situation where we stumble upon not Q being a false statement. Ooh, there should be an arrow. Oopsies. That slightly changes what I was trying to say. So we're trying to find a situation where when we this, the negation of this, which I'll just write over here, I guess, to make it easier to find, trying to contradict this statement where both A and B are not equal to 0. This is really easy. You might have already found it. Multiply both sides by 1 over A. This is cancellation of multiplication law. Then we can rearrange the left side so that the 1 times A and the A are next to each other. So this would just be multiplication dissociative. Again, we got 1 times B equals 1 over A times 0. That's the multiple inverse. And then we're going to have 1 times B equals 1 over A times 0. We can say B equals 1 over A times 0 from multiple identity. And we have B equals 0 because A times 0 equals 0. And that's one of the theorems from 2.2. And now what we see here is this directly contradicts here, which means we've reached a contradiction to what we assume to be true, which means we finished our proof. We have now been able to prove P then Q is true. And instead of writing QED here, we write this symbol that looks like a circle with an X in it, and it basically means QED, and we have reached a contradiction. B equals 0 is contradicts B does not equal 0, which we assumed to be the conclusion earlier. But you don't have to write all that, you just put a circle and an X in it, and that's it for a proof by contradiction. Alright, that's it.